Welcome back to the Fullerton College Printing Technology Department. This is Professor Ben Hewitt, and we're going to finish out the last overview of the graphic communications industry done via the PIA Pre-Press Trainee Program, Section 5.1, Reproduction Models. So here we go. We're on to lithography now. At the time of publishing, lithography was the premier, absolute, world-beating, best method of printing and most popular for the most common products produced. It still is today, although its market share is being slowly overtaken by short-run, short turnaround specialty printing digital devices, which we'll get to at the end of this lecture here. So it does things like books and magazines, maybe not National Geographic quality magazines, but most normal magazines are done this way. Reports, newsletters, did I mention books, postcards, business cards, all sorts of things are done this way. It's fairly standard for commercial printing. This whole thing is built around the kindergarten science experiment that hopefully you've all done back in kindergarten if they haven't standardized tested you to death, which is when you put oil and water in the same cup, they don't mix. You get this lava lamp thing going on with the oil floating up in the water and not actually combining because oil and water do not mix easily. I mean, you could do it if you add some acid and some heat, but at that point you're talking about cooking dinner, and I'm going to stop because I'm going to make myself hungry. Anyways, so you have the image area, which is oleophilic. By the way, that is one of my favorite words this semester, but not my favorite. My favorite comes in the color management sections when we talk about measuring devices, because there's one word that is better than all other words. No spoilers yet, but oleophilic's pretty cool. That means it likes ink or oil. There's also a hydrophilic, which is water-loving, which is the opposite of hydrophobic when you have rabies and are terrified of water. Anyways, so part of your plate likes oil, the other part likes water. They don't combine with each other, so the water and the ink, because the ink is oily based, don't mix. They repel each other down to thousands of dots per inch resolution. You're able to control this space simply through chemical differences. It's really dang cool if you ask me. It's not always practical, but it is very cool. Sorry, spoilers. This is me from the future, a few years after they published this thing, saying that, in fact, there are some more astounding technologies out there now that are more digital. But anyways, the surface is called planographic. Plano, like plane. Speaking of, here comes one, if you hear that flying over me. That would be a Mooney single-engine general aviation plane flying overhead. I do live near an airport. No, that's not a complaint. I'll let that pass. Should mention that I'm recording this outside because it's a nice day. Anyways, so the image area is not raised or recessed. It's not up, it's not down. The part that you want ink on and the part that you don't want ink on are even down to pretty much the microscopic level with each other. It's flat. The difference is chemical. Litho Stones. We have one on campus in our little mini bookshelf museum as you enter the printing lab, and I can show it to you sometime. Maybe I'll even give you a quick video. Originally, Litho Stones, lithography is called such because litho means stone in either Greek or Latin. Sorry, top of the head, don't remember. Take it back. Has to be Latin because Petra is in Greek. So it must be Latin. Anyways, so they used to actually be literally rocks, limestones, stones that were cut and polished smooth and then written on or printed on with greasy ink. And the greasy ink begets more greasy ink when you wet the stone, because I don't know if any of you guys have seen this, but limestone really does like to hold water on its surface. So you draw on the surface, do your artwork on the surface, print letters onto the surface, get it really wet, and then you rub ink on it, and the ink only sticks to the parts that don't have water on it. This was invented originally by a playwright named Alois Senefelder back in the 1790s, who was not a very good playwright. So the publishing houses that produced the plays, after they made one or two good flops, said, no more, sir, we're not publishing your plays. We lose money on them every time. And he said something to the effect of, screw you guys, I'll invent my own printing methods. But anyways, he not only invented the lithographic print process, he also more or less started the vanity printing industry, where you can have someone print your books for you to say that you had your books printed, whether or not a publisher actually backs you. Press units. On a printing press, as you can see in the picture here, there are many, I call them towers because it's a good way to think of them. There are many towers to a printing press. Sometimes there's only one. Each unit, each tower, contains all the things you need to print one color of ink through a litho system. Press units are also visible on other presses. Some flexo presses have multiple press units. Others have a very strange central impression system where they all go around one big middle wheel, but that's for another chapter, isn't it? Anyways, so a press unit is everything you need, the water and the ink systems and all the rollers to distribute them, the plate, the impression cylinder, all so it can print one color of ink. As many of you know, and some may not have experienced yet, in order to print normal color printing and normal color photo reproductions, you need 4 colors of ink. We use cyan, magenta, yellow, and black. C, M, and Y are our primary colors we use to mix the colors, and black is there to help us overcome the fact that though in theory it all works, in reality the math never quite adds up. There's a certain chromatic entropy to the world where you think red and blue are going to make purple, but in the end they don't quite get there because the pigments have to come from somewhere. Somebody has to make these inks out of chemicals that already exist in the world. And technically speaking, probably most of the best, most vibrant colors that the Earth was capable of producing, we've already used up. The particular plants and animals and shellfish that were used to make the best reds and purples and blues back in the days of the Renaissance and even the Middle Ages are now more or less extinct, and those colors can no longer be produced. And even they may not have been chromatically perfect for mixing with. The point is, everything comes from somewhere. You can't just magically appear with color. So you need black, and we'll get into this in more detail later in our classes. It's an important topic, and one of my very favorites. So let's go past that. Here we go. How it works. So you have a plate cylinder. You have a plate wrapped around the plate cylinder. Below that, going top to bottom, you have a blanket cylinder. Below that, you have the substrate, normally paper if it's going to be offset printing, passing between the blanket and the impression cylinder. The impression cylinder is there to make sure there's enough pressure pushing against the blanket. So the plate cylinder has the printing plate on it, and it prints the image onto the blanket. The blanket then prints the image onto the impression cylinder. Sorry, no, sorry, I said that wrong. Big flub there, mistake, another plane was going by. Sorry, I got distracted. Anyways, the blanket cylinder puts it onto the paper because the impression cylinder is pushing against it. If you're printing on the impression cylinder, that means you've run out of paper or have had a catastrophic paper jam and you have a lot of cleaning ahead of you. And I don't envy you if that's happened to you. It's not fun. It does happen to everyone at some point. So you'll notice with the letter C on the right column, on the plate cylinder, everything is right reading because you're not printing directly to the paper. This is why it's called offset lithography, because the plate is offset and does not physically touch the paper itself. So you can read it normally on the plate. It prints to the blanket, and every time you print something, it's like looking in a mirror. So because it printed to the blanket is now reversed or backwards or wrong reading, however you want to call it, mirrored. Wrong reading is the technical name for it. And then when that presses onto the paper, it's right reading. Anyways, that's how it goes. We're going to skip that because that video embedded thing does not work. So lithography has its advantages and disadvantages. One of the big ones is, compared to other large quantity printing systems, it is the cheapest and easiest to make a plate from. It is far faster and quicker to make plates for offset than it is to make make flexo plates or try to prepare screen printing screens. They're all a lot faster than trying to make gravure, where you have to actually etch metal either physically or chemically. That takes time. Litho plates, you just simply need to remove a coating from part of the plate because they all come pre-coated either as entirely image or entirely non-image, and use a variety of methods. Modernly, it's a laser to remove part of the coating. Either you're removing coating that does or does not like ink, depending on your plate maker and what it wants to do. And you have to buy the correct plates, or you are making backwards what you want to make. Anyways, that's a lot easier to make those than it is to make other plate systems. And it's able to print on a lot of different variety of substrates. What they really mean here, because honestly, let's be real, what prints on a variety of substrates is flexography. That prints on anything. And screen printing is the universal print system. You can walk around screen printing your friends' backs while they're not looking, although they'll feel it and probably stop you. But I'm just saying, screen printing will print on literally anything. The world is your substrate. Lithography, hi puppies. That would be my dog Monty, woof woofing because he saw something on the fence. Anyways, what they mean by a variety of substrates is a variety of thicknesses of paper. It can print on really thin papers, like the kind of papers you'd find in a Bible, a modern Bible, or a modern dictionary, the very, very thin paper, because you can have a really thick book, you don't want it to be too heavy. You can print on those. And it can print on pretty much heavy cardstock. You can print on really thick stuff for business cards and postcards and light stand-up, pop-up display type things. Good stuff. The disadvantages is it's hard to deal with that ink-water balance because the whole time you are managing two different systems. The water and the oil fight against each other, but if any one of them gets too strong, it wins. If the water wins, you get no picture. If the oil wins, your whole paper's covered in ink. So you don't want either one to actually win. You want them to be forever in tension. And you have to maintain this balance. And it's just something to keep an eye on the whole time. So that's a bit of a tricky thing. Also, even with it being a lower cost plate, it's still a plate and there's still a lot of setup involved. So really, you're not making a profit printing with this stuff until you get to a quantity of about 500 to 1,000 copies. Below that, you're maybe breaking even or probably losing money on the job or just charging way too much and clients won't want it. So let's talk about non-impact